Hello everyone, welcome to my effective C++ class. Today we are going to talk about const. In today's lecture, we are going to cover 4 topics. First, the concept of const. Second, the pointer and reference and const. Third, we talk about how to cast of constant objects. In the end, we talk about the benefit of using const. So the key point for here is the const is a compile time constraint that an object cannot be changed. Now let's get started. We define 2 variables, const integer c is equal to 1. To make the comparison, define regular variable nc is equal to 2. Now, once I define the c is a const, I cannot change the c values to other value, so that is illegal. If I compile this, they will report error. When the const interacts with the pointers and the reference, things will become tricky. Now let's see an example. Const integer star point cd is equal to point some values of c. So what that mean? Const integer star pcd. In this example, my data is a const, but the pointer themselves is not const. What that mean? The pointer themselves is not const means I can use this pointer to point some other variables, nc. That is okay. What that mean? The data is a const. The data is a const means I cannot use my pointers to change the values. That is illegal. Now, my PCD point to nc. nc is a regular variables. Although I cannot change the value of PCD, but I can change the value of nc. Once the value of the nc is changed, now my pointers point to the value is also changed. So the output is star of PCD. Compile the file, you see the value already changed to 7. So this example shows the constant data pointers. We cannot change the values through the pointers, but I can change the values through the variables the pointer pointed to. Similar things happens for the reference. If I define constant integer reference point to nc, so I cannot change my values for RCEF, but I can change the value for nc. Now let's talk about the constant pointer. The constant pointer, give example integer star const cp constant pointer is equal to c. So what that mean? That means my pointer is a const, but the data is not a const. So what that mean? That means my pointers, I cannot use my pointer to point some other values. So if I now suppose I define another variable of integer nc2 is equal to 7. Now I cannot use my PCP to point to nc2. That is illegal. So that means my pointer is a constant. However, the data is not const, which means I can use these pointers to change the values. That is okay. One thing I want to point out for here is the data is not a const, so I cannot use these pointers to point to some of a constant values. So let me give you an example. This is illegal. If I use this one to point to a constant value, that is not okay. That is illegal. Because in the left hand side, that means the data is not constant, So I can use my pointer to change the data. But in the right-hand side, the C is a constant variables. So left-hand side and the right-hand side are self-contradiction. So that is not okay. Similarly, if I use a reference like to point, this is also not okay, because in the similar reason as before, in the left-hand side, that means my reference can change the values, but in the right-hand side, is C is a const that cannot be changed. That is a self-contradiction. People may ask the question, is there any way we can have a constant pointers to point to the constant variable C? The answer is yes. So const integer star const pcp2, if I define it this way, that's okay. So what that mean? That means my pointer is a const, and also the data is a const. Because the data is a const, so this pointer can point to the C. The pointer is a const means this pcp2 cannot point to some other variables. To remember the role for these two const in the right side of the star and the left hand side of the star, that is easy to read from right to the left. So const star means the pointer is a const. Const integer means the data is a const. Now let's think about this. Is that okay for this one? Const integer star const pcp3 is equal to, let's see, is that okay? That is okay. So what that mean? So the const integer, that means my data is a const. So I cannot use this pointer pcp3 to change the values. Star const, that means my pointer is a const. That means I cannot use the pcp3 to point to some other variables. So although I cannot change the values through the pointer pcp3, but I can change the values from nc, because nc is the non-constant variables. Sometimes instead of write const integer, people write integer const star const pcp4 is equal to nc. So that is the same as in the previous line. So const integer and integer const, there's no difference. The only difference is the const in the right hand side of the star or in the left hand side of the star. It doesn't make any difference from integer const or const integers. Now let's talk about the const. Let's make an example. Suppose I have the integer I is equal to 2. Let's make the example. Now I have defined the const integer reference and also const integer star pointers. It also point to I. Now in this example, both the reference and the pointer is a constant data type, so I cannot to change the values through the reference or the pointers. To enable me to change the values, I use the constant cast integer reference ref go to, for example, 11. That is okay. Similarly, I can also use a constant cast integer pointer to prt and to change the values is 23. That is also okay. So that's the okay. However, if I define my const integer I is equal to 2, my code can still compile, and so that will lead to undefined behaviors. This is a bad behavior. By the C++ standard, once the defined variable as a const, you cannot change through their life cycles. Now, in the end, let's summarize. So, the benefit of using const have two immediate benefits. To use a const is a very good way to communicate with the compilers and also the very good way to communicate with other programmers. It will guard against inadvertently to write the variables. It's also a good way for self-documenting. That enables the compilers to do more optimizations to make the code tighter. And in the end, if you do the embedded device programming, const means the variable can also put in the ROM. That's all for today. In the next videos, we are going to cover how the const interact with the class and the functions. Thank you.